Hello everyone, good day. Today I'm discussing about the integration of exponential functions. Okay, so here are the following here are given on how to integrate exponential functions. Let's say for example you have ex dx that's just equivalent to ax plus c. And for the other example, that's ax dx, that's equivalent to ax over ln of a plus c. Okay, an example of this one is just, for example, you have the integral of 3x dx, that's equal to, um, that's 3 raised to x over ln of 3 plus c. Okay, that's it for that example. Do not forget to box your final answer. All right, let's move to the following examples on how to integrate number 1. Integral of e raised to negative x dx. All right. So to get the answer of this one, you are going to let u as negative x. Okay. Then du is equal to negative x, or sorry, that's negative 1 dx. Okay, or that's negative dx. Because we cannot integrate directly e raised to negative x because the given is just e raised to positive x. Okay, so in order for us to get or to integrate that one, we should get the u first. So that it would be eu du. Now then, if it's in eu du, then we can integrate that one. Okay, so what is the equivalent of du? That's dx. So step 2 is to change all in terms of u. So you have e raised to u. Okay, so your u is equivalent to negative x. So that's your u. Then your dx, okay, is negative du. Okay, so let's change this one into negative. Change this one into positive. So that's negative, okay, times negative du. All right, so therefore we can say that this is negative integral of eu du. Okay, next step is we can now get the value of eu du, the integral of eu du, that's eu plus c, right? So that's negative of eu plus c. Change u back into the form of x, so that's negative e, negative x plus c. Now this is your final answer. Okay? Okay, how about for example number 2? So that is 2, or sorry, the integral of e raised to x times the square root of 1 plus ex dx. So how are we going to get the integral for that one? So let's try to let u as 1 plus ex because by far some of the examples that we have done, we are going to let u with an exponent, right? So for this example, you let u as 1 plus e raised to x. But for some cases, this does not work. So if this does not work, then you can just distribute ex times 1 plus ex raised to 1 half. Okay, you can also do that if this does not work. So let's try first. So what's the derivative of ex? Okay, in your differential calculus, the derivative of that one is equivalent to ex, still ex, right? Okay, derivative is d over dx. So d over dx is equal to ex, so you just simply put dx here. All right? So what is, okay, so we can change this one in terms of u, right? So that's integral of ex of dx is equivalent to u. Notice that ex dx is du. Okay, let's put du. And then 1 plus ex, that's u. So that's 1 raised to 1 half. All right, now you can use the power rule. So therefore, this is just equivalent to u 1 half plus 1 over 1 half plus 1 plus c. All right, so guys, some of you do not put plus c. Some of you do not put plus c if this is done already, or if nawala na to siya, you don't put plus c. Mind you guys, that is not correct. Okay, I'm still considering that one. If you do not put plus c there, if the integral is gone, then that is incorrect. Okay, even if your answer has plus c. So let's follow some orders here, okay, some steps. So that would now be equal to u 1 half plus 1. So u 1 half plus 1, that's 3 halves, correct? So that's u 3 halves over 3 halves plus c. Right? Simplifying your answer will lead us to 2 u. Okay, what is your u once again? Your u is 1 plus ex times 1 plus e raised to x, 3 halves, over 3 plus c. Now this is your final answer. All right, very easy, right? Okay, for number 3, so let's say we have this given x squared e negative 2x cubed dx. All right, so for this example, we are going to just let u as, oops, ana. For example, we let u as negative e raised to negative 2x cubed. Would that be correct? Okay, let's try. If we let u as uh, negative 2 or e negative 2x cubed. This is just a trial, okay? Trial can also be wrong. So du is equivalent to e raised to negative 2x cubed times the derivative of negative 2x cubed, that's negative 6x squared dx. Okay, so notice that um, we are quite lost here, right? So we are quite lost here, meaning to say that our trial will lead us to a more complicated solution. Therefore, let's erase that one and find another way. What should we use, or what should we let us use to find the answer, but in a non-complicated way? So therefore, we can do this. U is equal to negative 2x cubed. So your du is equivalent to negative 6x squared dx. Okay, so we have x squared dx. We just need to divide both sides by negative 6. So therefore, this will be deleted here. Therefore, d over 6, or sorry, x squared dx is equivalent to negative d over 6. Now, therefore, we can easily substitute that one already to in terms of u. So what's left is x squared dx is negative d over 6. Okay, and then e negative 2x cubed. So e negative 2x cubed is your u. So yes, we can already integrate this one. We can integrate this one because all of it is in terms of u. Now we just need to simplify. Let's do it like this. So igawas na to si constant. Constant will be outside of the integral sign here, or the snake sign. Okay, so that's negative 1 over 6, integral of EU. Then what's left here is du. Therefore, that's negative 1 over 6. The integral of EU du is just EU plus c. So e raised to negative 2x cubed plus c. Now, this is our final answer. Okay? All right. fourth example. Let's say, for example, we have the integral of ex times 3ex minus 2 squared. Okay, how should we answer this one? So this is equal to, okay, we are going to let u as what here? Let's try 3ex minus 2. So what's the du of this one? This is du equals 3ex minus 0. So that's directly this one. Okay, divide both sides by 3. So your ex dx will be equivalent to du over 3. Yes. Oops, we forgot the dx sign here. So take note, class, that ex dx is equivalent to d over 3. Yes, that is correct. So change back in terms of u. So 3ex minus 2, that is u. So that's u squared. Okay, that's u, right? 3ax, this is u. Then this is squared. Then ex dx is equivalent to d over 3. Okay, therefore that's u squared du over 3. Okay, then the constant will be outside. So that's 1/3 integral of u squared du equals 1/3 u cube over 3 plus, okay, that's multiply, plus c. Okay, so therefore this is u cube over 9 plus c. Change in terms of x. What's your u? Your u is, okay, that's 3ex minus 2. So that's 3ex minus 2 cube over 9 plus c. Now, therefore, this is your final answer. All right. Okay, for the last example, before I give you your exercise, let's solve this one. For e sine 2x cos 2x. Now, this is a bit complicated if you see, but it's not. Okay, so mahadlok na dayon mo, no? Do not be scared. You just simply do the u substitution form for this one. Okay, but in some parts, no, the u substitution might not work. So there are other integration techniques that we need to learn first. So for this one, yeah, let's try the u substitution as the exponent of e para magiging e u du. So let's try u is equal to sine 2x. Okay, our goal is to change this one into EU du form. That's why so that we can integrate, right? Because we cannot integrate if it looks like this, no? So let's try. So du would be equal to 2 cos 2x, right? Because the derivative of sine 2x is cos 2x. And then multiply it with the derivative of 2x. So that's 2. So therefore, that's 2 cos 2x. All right. So our dx is, our cos 2x dx is equivalent to du over 2. Okay. As you can see, again, cos 2x, that's du over 2. And then, see, e sine 2x, that's e raised to u. So if we put that back into the original form, so ilalabas natin si 4, and then e raised to u, our sine to x is your u, right? Then cos to x dx, again, that's d over 2. Okay. So if we take 1/2 outside, so 4 times 1/2, that is 2. So ang maiiwan is just eu du. Okay. Then 2, the integral of EU du is just equivalent to E u plus c. Again, what is our u? That is sine 2x, correct? So that's 2e sine 2x. Oops. Sine 2x plus c. This is our final answer. Okay, so that's it for exponential functions. Expect another video for logarithmic equations, or yes, logarithmic. Sorry, that's inverse. Our next topic would be inverse trigonometric functions. So thank you for listening. Hope you will have a great day. Bye bye.